So following on from the previous video, we got to this stage here where we are trying to investigate something that we know nothing about, which is this series, and we should compare it to something that we know something about, which is this series. Well, in order for us to use a limit comparison test, we would need to compute an divided by bn. We would need to compute an divided by bn. So we would need to compute an, so this is our an, divided by bn, so this is our bn. Okay, so we need to compute this value here. So computing this value here, as n heads towards infinity, this thing here will head towards 0, 2 to the power 0. 2 to the power 0 is 1. 1 take away 1. The numerator will be 0. As n heads towards infinity, the denominator will be 0. 0 over 0 is an indeterminate form, so we will need to use L'Hopital's rule, meaning we have to differentiate the top, differentiate the bottom. So you should know how to differentiate this by now. We've done this in the past. So if you differentiate this, you should know how to differentiate this by now. So if you differentiate it, it will then give you this thing here. So hang on. So we were at this stage here. As n heads towards infinity, you're going to get 0 over 0. So you can apply L'Hopital's rule. So applying L'Hopital's rule, differentiate this. That will then give you this. By right, remember this here is a discrete sequence. And then, but in order for you to use L'Hopital's rule, you need to map a continuous function on top of this. But let's just keep it simple. Let's forget about that continuous thing. So differentiate the top using L'Hopital's rule. Differentiate the top. That will then give you this thing here, and then differentiate the bottom. That will then give you this thing here. So now if you look at this, so hang on. If you differentiate this, it will then let me start again. So we are currently here. So using L'Hopital's rule, differentiate the top. That will then give you this. Differentiate the bottom. That will then give you this. So now this thing here will cancel out with this, and then leaving you with just this. So as n heads towards infinity, this will be 2 to the power 0, which is 1, and then 1 times this, it will be this. So as n heads towards infinity, the limit is natural log of 2, which is this thing here. So going back to the very start, so remember, we've just computed this value here. It turns out to be natural log of 2, which is less than 1. So going back to the very start, we computed this value here, and it turns out to be natural log of 2, which is greater than 0 here. So we would need to look at this scenario here. Well, this scenario here is saying that the thing that we're trying to investigate, compare that with something that we know about. Well, they must both converge, or they must both diverge. Well, this series here diverge. We know that this series here diverge. Therefore, the thing that we're trying to investigate. So hang on. This is our an here. This is our bn here. Well, this scenario here is saying that they both converge or both diverge. So they both converge or they both diverge. Well, this series here diverge. Therefore, an here must also diverge. So therefore, our series here diverge. Okay.